Hi, this is Randy with Sophos Tutor, and I just want to say thank you for clicking on this video. Also, if you haven't already, please click subscribe to Sophos Tutor so you don't miss any of my future videos or office hours live streams. Thanks.
So the problem that we're going to look at today is from SAT Practice Test 7, the calculator section. It's problem number 36. It's a gridding question involving trigonometry. And I've gone ahead and listed the key piece of information on the right, but I will still go ahead and read the problem. In the figure above, tangent B is equal to 3 over 4. If BC is equal to 15 and DA equals 4, what is the length of DE? First thing I want to do is make sure I label what I'm looking for. In this case, DE. I want to make sure I label that with the variable x. Okay, x marks the spot. Next thing I'm going to do is I'm now going to label any equations onto my figure. So BC is going to be 15. I'm going to go ahead and draw a line just to make sure that the entire section is labeled as 15 and that DA is 4. So I'm going to put a 4 right on the outside. Now, I think the big question is, how do we represent tangent of B? Well, first we know that tangent of anything represents the opposite side of a right triangle divided by the adjacent side. What's important to note, though, is that this is a ratio and not an expression of the actual lengths of the sides. So this doesn't mean that the opposite side has a length of 3 and the adjacent side has a length of 4. It means that the ratio between the opposite side and the adjacent side is 3 to 4. So the way that I like to label any kind of tangents is actually with a multiplier. This is known as a scale factor. So if B is up here, okay, let's take a look at the smaller triangle. The opposite side is DE and the adjacent side is DB. Since the ratio is 3 to 4, I'm actually going to write these as 3y and 4y. With y, in this case, being the scale multiplier or scale factor of the triangle DBE. Likewise, we can also create this ratio between the opposite side of the larger triangle and the adjacent side of the longer triangle. So we could say that the opposite side, AC, is equal to 3z, and BA would equal 4z. Okay, where z is going to be the scale multiplier slash factor of triangle ABC. Now, what does this mean for the hypotenuse for both the smaller and the bigger triangle? Well, we can take a sample triangle of 3 and 4. Okay, let's force this triangle to have sides 3 and 4. What would be the hypotenuse? Well, if we plugged into the Pythagorean Theorem, we know that a squared plus b squared is equal to c squared. So in this case, 3 squared plus 4 squared should equal question mark squared. 9 plus 16 is equal to that question mark squared. 25 is now equal to that question mark squared, which means the question mark is equal to 5. Which means that we can label the hypotenuse of the smaller triangle as 5y, and we can label the hypotenuse of the larger triangle as 5z. Now notice we already know that the hypotenuse of the larger triangle is 15. So therefore 15 must equal 5z. And if we solve that, if 15 is equal to 5z, 5 by 5, we see that the scale factor is equal to 3. Now that we know the scale factor is 3, we now know the lengths of all the other sides. Since z is 3, we now know that AC is going to equal 9. And we know that AB is equal to 12. So now that we know that the actual length of AB is 12, we know that AD is equal to 4. Well, now we can figure out what BD is, which we already know we've labeled as 4y. Well, if the whole length is 12, we subtract 4, which is dA, we're left that BD is equal to 8. And since 4y is now equal to 8, we can now solve for the scale factor of the smaller triangle. In this case, the scale factor of the smaller triangle is equal to 2. And since we know that 3y is equal to x, we're just going to go ahead and plug in 2. And we realize that x is equal to 6, which is our final answer. So what's the main idea that I want you to get from this trigonometric question? Is that whenever you have a trig function and you are able to identify the proper ratio, you actually want to attach a scale multiplier to both the numerator and denominator of the fraction, right? So notice that every time we labeled opposite or adjacent, we labeled it as 3y over 4y, or 3z over 4z. And every triangle has one scale factor, right? Y and z are scale factors. Once you solve for those scale factors, then you can solve for all the sides of a triangle.